GM everyone, and welcome in the first video of Alchemy Road to Web3. I am Vito, and today I want to walk you through the development of your first ERC721 smart contract or NFT smart contract and how to deploy it on the Rinkeby testnet. So how to do that? Before going through the technicalities and the code, I've prepared a couple of slides for you to walk you through what you're going to learn and how you're going to learn it and what you need to learn what's contained into this video. So let's get started. First of all, I am Vito. I am a developer advocate at Alchemy, Twitter content creator, and full-stack Web3 developer. Before that, I was a full-stack old-school Web2 developer, now completely transitioned into the blockchain, here to help you do the same. So there are a couple, actually just one prerequisite to go through this lesson, and is having some familiarity with programming languages that can be easily translated with we need you to be curious to learn how the blockchain works, how smart contracts work, what are gas fees, how to deploy onto the blockchain, and so on and so forth. But don't panic, we'll start from the complete basic of smart contract development to walk you through and become a Web3 full stack developer by the end of this 10-week course. Before going deeper into it, let's see what is a smart contract very briefly. So smart contract is nothing more than a piece of software that runs on a decentralized network of nodes. So if you're familiar with the concept of blockchain, you might know that it's a network composed of different computers all sharing the same copy of the blockchain of this huge public database. A smart contract for Ethereum and other blockchains such as Solana is nothing more than a piece of software that's being deployed on one of these nodes and then copied all over the network. So everyone will be able to access it, call your smart contract, and use it to get responses, mint NFTs, get ERC721 tokens, crypto coins, and so on and so forth. And in this video, we're going to develop and deploy our first smart contract. But what do you need to develop a smart contract? Well, you need mainly four things. You need Solidity, or in case of Solana is Rust, but in case of EVM compatible blockchains such as Ethereum virtual machine compatible blockchains, you'll need Solidity. So we write a program in Solidity, and then we'll deploy our program using a node, such as Alchemy in this case. So why that? Because every time you want to deploy your decentralized application onto the blockchain, you want to deploy your smart contract onto the blockchain, you will need a node. And you have two possibilities. The first one is spin up your own node. That means you need to download software and maintain your node and sync to the blockchain. It might require weeks to do so. Or you can use a hosted node provider such as Alchemy and make your life way easier. Also, it's completely free. So you won't have to pay a single penny to create your Alchemy account or kickstart your Web3 development journey. Other than that, you will need a developer environment. Here as well, we have two possibilities. The first one is using a local developer environment, such as Hardhat, but it comes with some complexities to set this up. So in this video, we will go through how to use and host an online IDE integrated developer environment, such as Remix IDE, that is being specifically made for smart contract development with Solidity, and it makes our life much easier. Last but not least, we will need some cryptocurrency to pay for our gas fees. So if you're not familiar with what are gas fees, well, I prepared a slide for you, and maybe you're familiar with gasoline and the fact that whenever you need your car to bring you somewhere, you need to pour gasoline into it, enough gasoline for your car to bring you to your destination. And the same applies for smart contracts and actually any operation you will accomplish on the blockchain. So anytime you will need to deploy a smart contract, call a smart contract, run a transaction, you will need to provide your transaction with enough gas to actually bring you to destination. So to be more precise, let's go and watch this diagram. So as you can see here, we have a program counter. So we have some kind of laptop computer or device that is interacting with the blockchain, and we're providing it with some gas. And then we call our EVM code, so our smart contract code, onto the blockchain. And this code probably will run operations such as writing on the stack, writing on the memory, calling other smart contracts, or I don't know, creating an account or creating another smart contract. All of these operations will cost you some gas. So whenever you run an operation, it will pay gas. Whenever you create an account, you will need more gas. So what happens if you don't have enough gas? Well, your transactions, your operations will be reverted back and nothing will actually happen. There are cases where you might not receive back your gas, but this is too technical for this video. So just bear with me that whenever you run an operation on the blockchain, you will need to pay some gas. And in this case, we will use Rinkeby testnet to deploy our smart contract because we don't want to use real money, right, to learn how to deploy smart contracts. And testnets are specifically meant for that. So you can require test ETH that is completely free and test your deployment without paying a single penny. Now, what will you learn during this week? This is probably the most important thing for you. First of all, you will learn what is a smart contract and what do you need to deploy one, to develop one. Well, surprise, you just learned that. We learned that we'll need Solidity, that we'll need a node, that we'll need a developer environment, and that we'll need some cryptocurrencies to pay for our gas fees. But other than that, you will learn how to write an NFT smart contract, an ERC721 smart contract, how to get free test ETH on Rinkeby using rinkebyfaucet.com, and then you will learn how to use Alchemy, how to create your free account and kickstart your Web3 development experience. Last but not least, we will learn how to deploy it to the blockchain, again, Rinkeby testnet, and interact with our NFTs on OpenSea. But better than that, this is a 10 weeks program that will allow you to have weekly challenges. And every time you will complete one of these weekly challenges, such as developing your ERC721 token, you will get an NFT that will allow you to prove that you have actually learned that you actually have deployed and developed an NFT smart contract onto the blockchain. But other than that, you will meet an awful lot of developers ready to help you out and doing the same and on your same learning journey. So ready to team up to create experiences and applications all together. And for this week is actually hidden under my webcam image. All right, much better. So as you can see there, this is the NFT you will earn completing this week project. So what can I say? Good luck. Let's get started with the code and how to develop and deploy your ERC721 token on the Rinkeby testnet. The first thing to do is navigate to OpenZeppelin.com and click on Products Contracts. If you're not familiar with what OpenZeppelin is essentially a huge repository, a huge maintainer of smart contract standards that are secure and thoroughly audited. So what do I mean by that? When you're writing smart contracts as a Web3 developer, the first concern you should have is security, because a lot of malicious actors will try to exploit your contract, steal your funds, or mint more NFTs than what you planned for, right? So what we want is a smart contract that is secure and very hard to be exploited. You have two ways to do that. The first one is to create your own smart contract and create your own ERC20 smart contract and ask a company to audit it, or use services such as OpenZeppelin to create your smart contract, being sure that the libraries you're using have been thoroughly tested and are secure. Now that said, click on Get Started and you'll be brought to the documentation. And if you click on the second item here on the left-hand side menu, you see Wizard. So the wizard on OpenZeppelin is an amazing tool that will allow you to create a very simple ERC721 or ERC20 or ERC1155 smart contract boilerplate without having to write a single line of code. So let's see how it works. First of all, let's scroll down. As you can see here on the top left-hand side menu, there are 3 items plus 1. There are the ERC20. If you're not familiar with what ERC20 is essentially the cryptocurrency standard. So if you want to write a token that is a cryptocurrency, you will use the ERC20. The ERC721, that is the standard that we will use, that is the NFT standard, and the 1155 that is more used for inventories and games, and is a smart contract that will allow you to both store ERC20, ERC721 tokens in the same, right? In this case, as said, we want to write an ERC721 because we want to write our own NFT collection. So let's click on it. Here, as you can see, you will have to choose the name and the symbol of your smart contract. So I'll go on and I'll write Alchemy here and Alch. Just for the sake of clarity, this name will be used by marketplaces such as Rarible or OpenSea to write the name of the collection you're deploying, in absence of a contract URI metadata. But we'll see what is it in a few minutes. Just bear with me and give it a fancy name that you would like to see as a collection name for your NFTs. Second, there is the base URI. You can just ignore it. We won't need it in this video. The thing that we'll need though is add a couple of features, because first of all, we want our NFT to be mintable. So we want users to be able to mint our NFTs, of course, right? Then we want auto increment IDs. The thing is, we want to give all of our NFTs a unique ID. So how do we do that? We can use a library that will allow us to keep track of our IDs, such as the counters library. That's why we're adding auto increment IDs. If you're unsure of what one of these features is doing, well, you can simply hover over the toggle here and look for the explanation, or you can scroll down on the left-hand side menu and click on ERC721 here and look at all the information, all the methods contained into this library, such as safe mint and so on and so forth, owner of, balance of. And if you click on one of these methods, the documentation will very clearly explain to you what this method is doing. Now, back to the contract wizard, we need another couple of things. We need enumerable and we need URI storage. Why that? First of all, enumerable will give us the possibility to check the balance of an account, so how many NFTs an account has, and the URI storage will give us the possibility to associate metadata to our NFTs. Before going on though, I want to spend a couple of words to explain you what is the metadata and how the metadata will be used by popular marketplaces to show your NFTs. So if you navigate to OpenSea and if you click on one of these NFTs, so for example, let me go here, this is a collection search woman passport, I can click on here, amazing, and we have a title here. As you can see, we have a bunch of things going on, such as a title, such as an image, description, and properties. All of this information is contained into the NFT metadata, into a URI. If you're not familiar with the concept of URI, it's very, very similar to the URL concept. So what is an URL? Is a place on the internet where you can find information. So every time you associate an URI with your NFT and on that URI there is some metadata, the marketplace will be able to read this metadata and populate this page, such as the image, the title, description, and properties, and so on and so forth. But how do we do it? How do we associate a token URI to an NFT, right? To a precise NFT? Well, again, if I go back to the contract wizard, I just selected the URI storage, and URI storage is implementing for us a couple of functions such as set token URI and token URI that are used by these marketplaces to fetch our metadata and populate that page that we just saw. Now, going back to the contract wizard, we don't need anything else. That's all we need. There are things such as burnable, pausable, and votes that might be important for you and useful for you, but are important for the sake of this video. Now, if you want to know more of what these things are doing and what's the utility of these properties, of these features, again, you can go to the ERC721 extension here into the documentation and look at things such as pausable and see what pausable is doing, such as useful for scenarios such as preventing trades until the end of an evaluation period. So let's say there is an issue with your trades, there is an issue with your community or whatever, and you want to pause transactions while you want to implement the ERC721 pausable library. The same applies for burnable. Burnable allows you to destroy tokens, so you might want to keep inflation low or whatever are your tokenomics features. You might want to include burnable, and so on and so forth, such as the ERC721 votes is for governance. I'll leave it to you the thing of reading the documentation just a little bit to get familiar with the ERC721 standard and extensions to better understand how you want to shape your ERC721 contract. But for the sake of this tutorial, again, we will only create a very simple NFT collection. So we won't need anything else than mintable, auto increment IDs, enumerable, and URI storage. Amazing. Now, next step, we want to modify our smart contracts just a little bit to better suit our needs, but to do so, we will use Remix. So let's go to Remix. If you go here, as you can see on the top right hand side menu, there is this button called Open in Remix. So just click on it. This will open up a new window, and this is the Remix IDE. As we said at the beginning of this video, we need an integrated developer environment or just a developer environment to connect to the blockchain and deploy our smart contracts to the blockchain. So in this case, we're using an online IDE that is, again, completely free and is specifically made to develop and deploy Solidity smart contracts onto the blockchain. As you can see, our code is now here, so we can modify it. Just to say briefly what this code is doing, well, at the first line, we have the SPDX license identifier. If you're not familiar with it, the Web3 idea is that code should be open source, and if not open source, it should be indicated. So what we're doing in the first line is we're indicating the kind of license we want to publish our code under. In this case, the MIT, that is an open source license that is allowing other users to copy our code, use for their project as well, but not for commercial purposes. Now, the second line is the pragma solidity, in this case 0.8.4. What is it? We're essentially telling the compiler the version of solidity we're using to write our smart contract, and we will need later on to actually compile our code. In this case, as you can notice here, there is this very small symbol that is essentially telling the compiler, yo, look that every version between 0.8.0 to 0.8.9 is valid to compile our code. Now, if you remove it, it means that only the 0.8.4 compiler version will be able to compile this code. In this case, we don't care. We're not using any kind of new feature or very old feature that would cause us to need older version of the compiler or newer version of the compiler or precise versions of the compiler. 0.8.x works perfectly. Then we're importing a bunch of libraries from the OpenZeppelin repository. So we're importing the ERC721 standard, that is the core ERC721 NFT standard. We're importing the ERC721 enumerable that we said before, the URI storage to associate URIs to our NFTs, ownable that will protect some of our functions from being used by other users that are not privileged. So we will see this later on. We are using the counters library, the counter extension that we will use to keep track of our NFTs ID. Then, if you're not familiar with OP, so object-oriented programming, no worries at all. But what we're doing here is we're initializing our contract. And contracts, again, if you're familiar with OP, are very, very similar to classes. So they have a name, in this case Alchemy, and they can have some sort of inheritance. So they can inherit methods, functions, variable, and so on and so forth from other smart contracts, parent smart contracts. In this case, we're inheriting functions from ERC721, the ERC721 enumerable smart contract, the ERC721 URI storage smart contract, and the ownable smart contract. Given then, the thing we're doing here is we're initializing the counters library that we will use to keep track of our NFT IDs, and we're creating a new variable that is a counter variable and is private. This is very, very important, and this is the thing I want you to notice. So there are things that can be private, public, internal, or external on Solidity. And what do I mean by that? Well, as we're meeting the first one of these, that is private. All the variables, all the functions that are marked as private with this keyword here will only be visible and can be used by the smart contract itself, inside the smart contract, not from inherited smart contracts, not from child smart contracts, not externally from users, but only inside the smart contract. So it's a thing about security, right? If you don't want your variable to be accessible from the external world, then you want to mark it as private. Amazing. Then we have the constructor. What is the constructor? Essentially, the constructor is creating the instance of our smart contract. And you can run operations into the constructor to populate variables or to assign names or whatever you need to do to build the instant of your smart contract. In this case, because we are inheriting from the ERC721 token standard, we want to run an operation to assign the name and the symbol of our smart contract. In this case, Alchemy and Alch. You can change the name of your smart contract as we did here before by changing the name here. So we can call a no-sum collection. In this case, I just do it as an example, but I will go back and call my collection Alchemy because I like the name and I like the symbol ALCH. Now we have the most important function that we'll find in our NFT smart contract, in our ERC721 smart contract, that is the mint function. If you're not familiar with the concept of minting is the action of writing a new thing onto the blockchain or creating a new entry onto the blockchain. In this case, we're creating a new NFT onto the blockchain, and we are associating to it an address, a token URI, and an ID. So what do we need to mint an NFT? Well, we'll probably need an address. So an address of a wallet or a smart contract, why not, that we want to send the NFT to. And now we'll need a URI. How do we say what kind of variable is it? Well, as you can see it here, Solidity comes with a type that is the address type, that is specifically meant to be used to assign, to create, to store addresses in the smart contract. On the other hand, we have the string variable, that is a series of characters that are composing a word or a string. In this case, the URI string, and we're saving it onto the memory. We won't go through what is the memory in this video. We will do it in the second week because it's a more technical concept, and I really want to get rid of all the complexities of understanding the technicalities of it. Last but not least, we're also marking this function as public and only owner. Do you remember we saw the private view modifier? Now in this case we're using the public view modifier. So the opposite of private, public means this function is accessible from anywhere. So users interacting with our smart contract from the outside our smart contract, or inherited smart contracts that are inheriting from our smart contract, will all be able to access our safe mint function. So bear in mind that all the things that have been marked as public will be accessible by anyone and everyone at any given time. Last, we have the only owner function modifier. Do you remember we imported the ownable.sol library? Well, what we're doing here, we're essentially adding a modifier that is telling Solidity, that is telling our smart contract, yo, if the person, if the wallet or the smart contract that is calling this function is not the owner of the contract, and what is the owner? Is the wallet or the smart contract that deployed this contract onto the blockchain, then block the transaction, revert the transaction. People cannot mint. Practically, anytime a user that is not you, because you'll be the one deploying the smart contract onto the blockchain, will try to call the safe mint function, then it will be blocked. Now, we probably don't want that, right? We want people to be able to mint our NFTs, no matter if they're us or not, because it might become really overwhelming, right? To have to mint NFTs for all of your users. You want your users to mint their NFTs on their own. So how do we do it? First of all, I'm gonna delete the only owner function modifier, and I'm gonna also delete the ownable library and here ownable from the inherited smart contracts. In this way, users will be able to mint NFTs on their own. Now, you might want to add some kind of logic to limit the maximum number of NFTs users will be able to mint. Bear with me, we're going to implement something very similar in a few minutes. But just for now, let me go through all the functions that we have in this contract so you can have a whole understanding of what's going on here. So if we go into the safe mint function, we can see there are 4 lines. The first line here is declaring a uint256 variable called token ID that actually stores the current token ID that the token ID counter is keeping track of. So we can call token ID counter.current and then the braces, and we can call this function that will give us the current number of token ID. The current token ID number. Then in the third line, the second line of the function actually, we are incrementing this number, making sure that the next NFT we'll create will have an incremental number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. Now, notice that at the end of every line in our code, there is a semicolon. This is super important. Without the semicolon, your code won't compile and will give you a huge headache because you will need to understand where that semicolon is missing. So just keep in mind that every time you conclude a line, every time you conclude a statement, you will need to add a semicolon. Now here, finally, we're actually calling the safe mint function, passing 2 things, the to address that we gave when calling this function, and the token ID that we got here using the token ID counter and the counters library. So here we're actually minting the NFT. Now, if you want to go deeper into it and better understand what the safe mint function is doing, well, again, you can go into the OpenZeppelin documentation, click on ERC721, make sure you are the right version of the documentation 4.x. Scroll a little bit and click on Safe Mint. You will see Safe Mint. You can search for Safe Mint here, click here, and you can see that Safe Mint will essentially create a new entry onto the blockchain and create your NFT and send your NFT to the to wallet address. That doesn't matter if it's a smart contract address or a wallet address. It will send the NFT to that address. Also, this will cost you some gas. Then, last but not least, we're assigning a token URI to our smart contract, to our NFT. Again, do you remember? The token URI is the URI containing the metadata that contains all the properties that will be used to populate our NFT page, such as properties, cheeks, eyes, ears, description, title, and image. Now, going back to Remix, we have another bunch of functions down here that are all overrides required by Solidity. What is an override? Well, probably in these libraries, in these parent smart contracts that we are inheriting from, there are a bunch of functions such as before token transfer, token URI, and supports interface that we need to override to perform other operations. So we need to copy from these parent smart contracts, rewrite those into our smart contract here in our child smart contract, and modify something to actually accomplish the operations that we want. In this case, we have four functions. We have the before token transfer function, the burn function, the token URI function, and the support interface function. I won't go through all of these because it doesn't really matter at this point. The only one that I want you to really understand is the token URI function, because it's the function that OpenSea and Rarible will call to get the URI of your token. So in this case, they will pass a token ID, for example 0 or 1, and get back the value of the token URI associated with that token ID. There are a couple of things though that I really want you to give attention to look for. The first one is that functions such as before token transfer is marked as internal. Now we saw public, we saw private, now we're seeing internal. Internal is very much similar to private, with the only difference that also contracts that are inheriting from our contract will be able to access this function. If you remember, private functions or variables are only accessible and readable from within the smart contract and not from contracts that are inheriting from our smart contract. But internal variable and functions are readable also from smart contracts that are inheriting from our smart contract. So contracts that are having our smart contract here. Other than that, we also have this view modifier. Now, this is another thing. It's not about public, private, internal, or external, but it's about functions that are writing onto the blockchain and functions that are just reading from the blockchain. Now, in this case, we're only reading, we're only trying to get the token URI of our NFT. So we're not writing anything. Now, what's the real difference though? Why do I need to mark a function as view? Well, that's a great question. The difference is that if you're marking a function as view and you're calling this function from your wallet and not from another smart contract, you won't pay any gas. This is different though if another smart contract is calling this function, because in that case, then it will need to pay some gas. You can read more on Google just by searching view function modifier. You will see an extensive explanation on how it works, but just bear with me and just keep in mind that view functions are functions that are not writing onto the blockchain, and potentially when called from your wallet won't cost you any gas. Last but not least, we have the support interface function that is not very important at this point, but is essentially telling anyone calling our smart contract if a certain kind of interface, a certain kind of feature is supported or not. Amazing. Now that we went through all of our smart contract, let's modify that a little bit to better suit our needs. So first of all, because we removed the only owner modifier, I want to add a certain kind of logic, a logic that will prevent users to mint more NFTs than the number of NFTs contained into my collection. So the thing that I can do is go on a new line here on line 12, go to line 13 and declare a new uint256. This uint256 will be called max supply. And I'm using capital letters because this will be a constant, and it's a good practice to use capital letters when declaring constants. And I will assign a number of 10,000 here. Remember, we also need the semicolon, otherwise our code won't compile. Then I want to move into the save mint function, and I will use a keyword called require. Require, if you're familiar with the if-else statement, is very similar to it. What it's essentially doing is we're telling him that we require something. So we require the token ID, to be less or equal than the max supply. If not, then we add a comma, we simply revert back the operation saying, I'm sorry, the max, all NFTs have been minted. That's it. So what will happen is that we will go through the token ID.current and will be 0 and then 1 and 2 and 3 and 4 till 999 and then 10,000 and then 10,001. And this function here, this require statement EL will kick in saying, yo, the token ID is not minus or equal max supply, is actually greater than it. Then I would revert back the operation sending this message that is, I'm sorry, all NFTs have been minted. Come back another time, right? Amazing. Now that we have this control logic, let's deploy, actually compile and deploy our smart contract onto the blockchain. First, we'll need to do a couple of things. We need to create an Alchemy free account. I will need to get some Rinkeby test ETH. Let's get started. First thing you'll need to do is move to alchemy.com, click on login, and log in with a new account or old account. If you're logging in with a new account, you'll see this onboarding process, right? So the first thing I want to do is select the ecosystem, Ethereum in this case, because Ethereum Rinkeby testnet is the Ethereum ecosystem. Click on get started, give a team name, in this case, Road to Web3, and an app name, in this case, Test NFT, or Cool NFTs. Let's call it Cool NFTs. And the network, I want to use Rinkeby. Now, it's deprecated just because we're approaching ETH 2.0 and Rinkeby is not a POS chain, a proof of stake chain. Just bear with me, it's perfect for now, as of now, to be used to deploy and test your decentralized applications and smart contracts. So let's just use Rinkeby and click on create app. We don't need to pay anything, so it's free forever. And we can add our payment details or we can simply skip for now. And if you click on about Alchemy on Twitter, you will get 85 million free views. That is around 30 million calls to our RPC URLs. You don't need to do it. You can simply skip, or you can post your referral code on Twitter. Now just skip for now. We don't need auto scale, so we can click on continue and we can click on let's go if you don't want to tell us how you heard about Alchemy. If you want, like write Road to Web3, that'd be great, and we might also give you some rewards. Now, next thing we want to do is click on Cool NFTs, that is the application we just created, and click on View Key. Then I want to copy this HTTP URL. Amazing. Now we want to move to our Metamask wallet. If you don't have Metamask installed on your browser, I will link up here a video that will walk you through how to create your first Metamask wallet and how to install it onto your browser. Now what I want to do is click on this network selection drop-down menu and click on add network. Then network name will be Alchemy Rinkeby, and the RPC URL will be the RPC URL we just copied. So it will be HTTPS, ETH, Rinkeby, and so on and so forth. Now the chain ID, if you're not sure which is the chain ID of Rinkeby, you can simply go on Google and write Rinkeby chain ID. And as you can see here, it's the 4. So I can write 4 here. Currency symbol will be Ethereum, ETH. Block Explorer, we don't need it. Just don't look at the error here. I thought it was a blocking error, it's not. You can simply click on save now. Amazing. Now clicking on our Alchemy, on our Metamask wallet, you can see in the network selection list, there are also Alchemy Rinkeby. Now next step is to get some free Rinkeby ETH. To do so, you can go on rinkebyfaucet.com. So I can click on my Metamask wallet, copy my account, my wallet address, paste it here and click on send me ETH. So again, rinkebyfaucet.com. Now I actually already requested my Rinkeby ETH in the last 24 hours, so it won't allow me to do so. What you can do though, you can request 0.1 Rinkeby ETH every 24 hours or up to 0.5 Rinkeby ETH. So what I want to do is log in with Alchemy. Now we're logged in. I want to paste my wallet address again, send me ETH, and now wait a couple of seconds because it's sending me the Rinkeby ETH. So I'll be back in a few seconds with the Rinkeby ETH. All right, now we have our Rinkeby ETH. It took us 20 seconds to receive them. and we can deploy our smart contract onto the blockchain. So let's go back to Remix. Now on the left hand side menu, as you can see here, you have this small Solidity logo. Let's click on it, and this is the Solidity compiler. Just make sure your compiler is into the range of compiler versions we'll need to compile our actual code. Leave everything unchanged, just tick on auto compile, because we want every time we write something on our smart contract, we change something on our smart contract to auto compile it, and click on compile contract. Now if everything went as expected, you should see this green tick near the symbol, but let's try to delete the semicolon as we said before. So I'm gonna delete it, and as you can see, because I have auto-compiled, it recompiled the smart contract, and now I have an error that is parser error expected the semicolon but got uint 256. So this is pretty confusing, and you will also have here the line, actually the line after the error has been found. So the error is on line 12 and the error is on line 13, and also the column, so in this case the 5th column, and it means that we're missing a semicolon here. So I'm gonna add my semicolon back, the error disappear, and we are ready to deploy our smart contract onto the blockchain. So let's do it. Click on this small Ethereum logo here, that is the deploy and run transactions menu, and look at this environment drop down menu. Click on it. We have many possibilities, many ways to deploy our smart contract. First of all, Remix gives us access to a JavaScript virtual machine that reassemble the blockchain functionalities. Now in this case, because we are using Alchemy and we're using Metamask, we can simply use those to deploy our smart contract on the actual blockchain, not just a copy on a virtual machine. So what I want to do is using the injected Web3. If you're not familiar with it, when you install Metamask on your browser, what happens is that it's injecting a property called window.ethereum, and this is exactly what Remix is using to connect to the blockchain. This window.ethereum parameter, this window.ethereum property will be used to connect to Alchemy and to the blockchain. So use injected Web3, as you can see here, is saying that we are on Rinkeby ID4 network, and we have an account with 0.061 blah 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 ether. Now I'm not sure this is the correct account that I want to use. No, I want to connect this account here, so I have 0.5 ether. Amazing. Now go under the contract drop down menu and select your Alchemy contract and click on deploy. This will open up a MetaMask pop-up window. Click on confirm. This is the estimated gas fees we'll need to pay. In this case, it's 0.007. And we have enough gas fees, enough ether to pay for our gas fees as we requested to the Rinkeby faucet. Click on confirm and wait a couple of seconds. If you click on your MetaMask wallet, you can see here that the deployment is pending. You can also go on Etherscan and keep track of your functions of your deployment. Now it looks like our smart contract has been deployed, and we have the confirmation here because under deployed contracts we actually have our smart contract and all the functions. Now it's very important that we notice that there are two kind of buttons here. There are orange buttons and blue buttons. What is the difference? Do you remember when we talked about view and read functions? Well, that's exactly the difference. Orange functions are orange methods, are methods that are actually writing onto the blockchain, whereas blue methods are methods that are reading from the blockchain. So for example, safe mint is something that we write on the blockchain because it has to create this NFT on the blockchain, whereas owner of or balance of or token URI are simply reading, are view function that are reading from the blockchain. Amazing. Now next step is to mint our first NFT, but first we'll need to create our metadata. So to create our metadata is very simple. You can move to OpenSea docs.opensea.io/docs/metadata standard, or just look for OpenSea metadata standard on Google and you'll find this page. It will also be linked in the description. If you scroll a little bit, here there is all the explanation of what the metadata is and how it works. There is this part that is metadata structure. So I'm gonna copy it. And here you can see there are also the attributes. So first of all, I'm gonna copy this one. And I'm gonna move to any kind of text editor that allows you to edit JSON code, such as VS Code, Notepad++, or in this case, I'm using a very simple JSON editor I found online, that is jsoneditoronline.org. Now, once you're on this page or using your text editor, your favorite text editor, just copy the metadata we got from OpenSea. and add these items into the attributes. So for example, you can copy those here, you can go down here, you can copy all of these items, go here and substitute the attribute property with the field attribute property. And what we need now is to write a description. In this case, I wrote a very simple description before starting this video, that is, this NFT proves I've deployed an ERC721 smart contract on Rinkeby. We will use the alchemy.com external URL, and then we'll need an image. So how do we upload an image? We will use a service called Filebase that will give us access to IPFS, interplanetary file system, with ease. So what we want to do here is go on filebase.com, click on login, and login. In this case, I will log in with my account, and you'll see this dashboard here. Now click on the left-hand side menu, buckets, create a new bucket. Now the thing is that the name of the bucket will need to be unique across all network. So in this case, I will call it Alchemy Road to Web3 T, and the storage network will be IPFS. Why are we using IPFS though? IPFS means interplanetary file system, and even if you have the possibility to upload your image on any kind of object storage or image hosting service, we want our image to be frozen, to be not changeable. We don't want to be able to change our image later on. So what we want to do is use IPFS because it will give us the possibility to upload the image and not give us the possibility to change the image on this URL. So if you associate an image to your NFT, chances are you want that image to be final, to be frozen, to be there forever. And how we do that? We use IPFS services. So I'm gonna use the storage network IPFS, create the bucket. Also, the bucket actually has to have only lowercase letters. So Alchemy Road to Web3 T, storage network will be IPFS, create the bucket. It will create a new bucket here. We can leave it private, and we want to click on the upload button. Now I will use the NFT image that is attached into the description. That is the one I will use to prove we have deployed as ERC721 token. So I'm gonna click on open. It will be super fast. Once it has been deployed, actually uploaded, we can go here and we will have this IPFS gateway URL. So copy it. If you click on it, you'll be redirected to the page where the image is hosted. This is completely free. You won't have to pay anything. And we can go back to our JSON online editor and change the image here. So now we have a HTTP IPFS Filebase yada 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 link URL that will bring us to the image. Then we want a name. In this case, I'm gonna call it ERC721 POC. This is not the POC you will receive at the end of the week. This is just for us to write a placeholder title. And then I want a bunch of trade types. Now, what are trade types? If we go back to OpenSea and we'll look at the profile at the NFT page, here if we scroll a little, we have properties and we have all these properties. This is actually what we're working with. We have the trade types. So the trade type will be the name. So in this case, let's call it coolness and say a lot. And then we have website, why not? And we want alchemy.com, and then we want token standard. You can write whatever you want, and will be ERC721. Amazing. Now we have all we need. Next thing is, let's save this document, this JSON document. So you can click on this save icon, or if you're using another editor, just save it and click on save on disk. And I'm gonna call it metadata.json. Keep it easy. In this case, I want it to be formatted. So I'm gonna click format save. Now this has created a metadata.json file. So I can go back to Filebase because we want to upload it on Filebase as well. We want to upload our metadata on Filebase as well, on IPFS as well. So I'm gonna click on buckets again, go back to Alchemy Road to Web3, click on upload, or I can simply click and drop our metadata.json file. My suggestion is try to rename the file if you can. So in this case, I'm gonna rename it because I already had a couple of files named the same way. So I'm gonna delete them. and I'm gonna rename this to metadata.json, metadata.json, and I'm gonna click and drop it again. So we have uploaded our metadata. We can check if everything went as expected here. So we have a page with some JSON on the internet that describes our NFT. So next step is actually add this link, this URI, and associate it to our NFT so that we can have a token URI, right? So we can have a token URI associated with our NFT. So what I'm going to do is go back to Filebase and copy this IPFS CID. So copy it. Why that? Because if you go back to the OpenSea metadata documentation, OpenSea metadata standards, and you scroll to the bottom of this page, you will have deploying your metadata API and then IPFS and then Rwave. And what they're essentially telling you is that they're expecting a link, a URI that is IPFS:/ and then the CID of your metadata. So the CID is the long string we copied from here. I will just need to add IPFS:/ before it. So let's go back to Remix and see here we have the save mint function. We can open the drop down menu, and here on URI we can write IPFS:/ and then the CID, and as the address we want to add our address. So I'm gonna paste it here. I'm gonna click on transact. My MetaMask wallet will open. Click on confirm, wait a couple of seconds. We can see on Etherscan or on MetaMask as well, our NFT has been minted. We can verify it by clicking again here, copying again our wallet address, go under balance of, that is a function that will tell you how many NFTs that address has. So copy the address here, call it, and it's telling us we have one NFT. Just to prove again, we can change the account, use my dev account, copy the address, paste it here, call it. 0 is a number because we have no NFTs minted in this account. And also, we can also check the token URI of our NFT. So I can open the drop down menu, and we just minted our first NFT, so probably the ID will be 0. So I can write 0 here. And here, as you can see, the string is IPFS:/ and then the CID of our metadata. That's amazing. Now, last step is to check if our NFT has been picked up by OpenSea. How do we do that? Well, you might know or might not know that OpenSea also has a testnet version. So you can write testnet OpenSea on the internet, on Google, and click on the first result. Then we want to log in. So I'm gonna log out because it's probably logged in with another account, and connect with Road to Web3. Metamask, click on Metamask. Now we have F076, and our NFT is here. Now, one thing you might notice is that there's no metadata here. Well, that's perfectly normal because OpenSea will take some time to actually fetch the metadata of our NFTs. First of all, you can click here, refresh metadata, and wait a couple of minutes, 3 minutes, 5 minutes, or up to 6 hours actually to see your metadata here. Now I will stop the recording for a bunch of minutes, for a couple of minutes, to see if OpenSea picks the metadata up, and we'll show you the final result. So it's taking some time for OpenSea to actually pick up our NFT, but what I want to show you is the final result. So we have the title here, we have the image, deployed an NFT, ERC721 token, our properties, and of course the details and the description for our collection. Now, if you want to go on and add other features to our ERC721 smart contract, go and do it. I will only give you this very small exercise, that is adding something in our code here that will prevent users from minting more than X numbers of NFTs per wallet. So what I mean by that is that if a user wants to mint 5 NFTs, that should be fine. But if they want to mint 10 NFTs on a row from the same wallet, then something in our code should block them. To do so, you might want to look into the concept of mapping and still using the required statement, the required keyword. Amazing. In this tutorial though, to recap what we learned today, we'll learn how to use the OpenZeppelin smart contract wizard. We'll learn how to create an Alchemy free account and how to create your own new application and RPC URL, dedicated RPC URL. We learned how to use Remix to create, modify, and deploy smart contracts onto the blockchain. We learned how to use Metamask to be our bridge between Remix and the actual blockchain thanks to Alchemy. And we also learned how to upload metadata, how to upload and build metadata to be able to see it on OpenSea. It's been a pleasure for me to have you here, and have a great one.